For millennia, the color purple was the ancient world's definitive visual marker of absolute power and extreme wealth. Synthesizing this specific hue demanded massive industrial resources and a sophisticated empirical mastery over marine biology. Behind the prestige of the toga was a putrefying extraction process that relied on the defensive secretions of hundreds of thousands of predatory sea snails. The sheer volume of biological material required to produce even a gram of pigment generated an extreme economic scarcity, an inelastic supply that empires would eventually learn to weaponize. Tyrian Purple operated as an early form of chemical social control, converting complex organic chemistry into a visual shorthand for imperial rank. This map illustrates the industry's geography. The Phoenicians industrialized the process on the eastern Mediterranean, centering on Tyre and Sidon. To maintain mollusk supplies, they established fortified colonies reaching the Purple Islands off Morocco. The source was the Muricidae rock snail. The dye is derived from a viscous fluid found in the animal's hypobranchial gland, used in the wild to sedate prey. The industrial math was staggering. Yielding just 1.4 grams of pure dye extract required the manual harvesting and slaughter of approximately 12,000 individual snails. This demand left permanent marks on the landscape. Excavations at sites like Tel Shikmona reveal massive mounds composed of millions of crushed shells, discarded after the glands were excised. The high cost of the dye was a direct result of this extreme biological scarcity and the grueling labor required to secure the raw material. Workers manually cracked the shells with stone tools to meticulously excise a gland, a process that required precise anatomical knowledge to avoid ruining the fluid. Thousands of these glands were salted and left to steep and putrefy for exactly 3 days to break down the organic tissue. Following this maceration, the mass was boiled in lead vats for 10 days. Dyers had to constantly skim the surface, removing the decaying mollusk flesh from the liquefying dye. Ancient artisans managed the vat's chemistry by introducing alkaline additives like wood ash or stale human urine to maintain a specific pH balance below 9. Catalyzed by sunlight and oxygen, the fluid reacted with UV light. It shifted through a metamorphic sequence, turning from green to violet, then a deep reddish purple. This process resulted in the ancient world's most stable pigment, a dye that was famously resistant to fading and often grew more vivid with age. By the 1st century, this level of stability had a price. A single pound of Tyrian purple was worth half the annual salary of a Roman soldier. To preserve the status of the elite, the Roman Empire enacted sumptuary laws, legislation that strictly regulated who was permitted to wear the color. The width of a purple stripe on a white toga became a legally codified barometer of a citizen's political rank. By the late 4th century, the state nationalized the industry. The highest grades of purple were reserved exclusively for the emperor to signal absolute, unassailable dominance. This exclusivity extended to architecture through imperial porphyry, a stone as hard as steel with a color mirroring Tyrian dye, symbolizing the unyielding Caesars. The state utilized this blood-colored cloth to make political hierarchy visible at a distance. Because wearing the color without permission was legally classified as treason, the fabric functioned as a constant reminder of the emperor's absolute legal authority. For centuries, the Byzantine Empire hoarded the secrets of murex production in state-run workshops, using the dye as a tool of high-level diplomacy. That monopoly was shattered in 1204 during the sack of Constantinople. The complex chemical recipes were lost to the West, and the murex industry effectively vanished for centuries. In 1856, 18-year-old student William Henry Perkin was attempting to synthesize a malaria drug when he noticed a deep violet residue in his experiment. He had accidentally created movine, the first commercial aniline dye. This discovery industrialized color production, making a hue once limited to emperors, accessible for the cost of a standard garment. Perkin's invention ended the era of biological exclusivity, but the association between purple and power persists as a cultural remnant of a social order